We're now going to look at factors of quadratics. What factors are going to do is help us find solutions eventually. What are factors? Factors can be numbers. Factors can be terms. Factors are divisors or divisors. And then last but not least, factors can be thought of as parts. A couple of terms I want to go over is actually term, okay? So a term when talking about equations or functions in math, they are separated by addition and subtraction signs. Okay, so a term is a part of an equation. So a part of an expression, a function, or polynomial that is separated by addition and subtraction signs. That's going to be huge when it comes to factoring. So I'll give an example. When I factor, okay, the first thing I want to do is find or list every term. So again, a term is separated by addition and subtraction. So 6x to the fourth y cubed, I see a plus. That tells me I have a new term coming to the right. So 12x cubed, I get to a subtraction sign. I now know I have a new term to the right of it. 18y to the fifth. Again, get to a plus sign, so I'm going to change colors and I'm going to highlight my next term. And again, terms can have variables. They can just be numbers. It doesn't matter. Again, the big takeaway is that they are all separated by addition and subtraction. Now, something that also makes factoring easier is when you find the prime factorization. Now, what prime factorization means is really just useful for the numbers or your coefficients of a term, but you want to reduce numbers to all prime. And remember, a prime number just has factors of 1 and itself. Okay. Now, the easiest way to go about making sure you have a prime factorization is to just start with a number. So I'm going to start with 6 since it's first. So 6, and then you do this factor tree. Okay, so you think, well, what times 6 is 6? You have 1 and 6. Well, 1 isn't a prime, so I'm going to mark it out. So 6, well, what else can be divided into, or what else can 6 be divided by? You also have 2 and 3. 2 is only divisible by 1 in itself. 3 is only divisible by 1 in itself. So I have now found the prime factors of 6, 2, and 3. A good habit to get into is when you get to a prime factor, either highlight it, circle it, make a note of it somehow, so when you come back to actually do this, or actually factor completely by GCF or any other method, is you can quickly find your factors. Okay, so now I'm going to do 12. And again, 1 and 12, but again, 1 isn't prime, so I'm not going to waste my time by doing 1s from now on. The numbers I like to start with are 2, because it's the smallest prime number. And if it's an even number, it's divisible by 2. And then I like to do 3, right? If a number adds up, or if the numbers inside of a number add up to be divisible by 3, then you know it's also divisible by 3. So 2 times what is 12? 6. And again, I know 2 is prime, so I'm going to circle that. 6 we just did, and it's also even, so it must be divisible by 2. I get another prime, so I'm going to highlight it. And then 3 is also prime, so I'm going to circle or highlight it. I then have 18. Now the signs in front of these numbers, they're not going to make any difference, so don't worry about doing, putting negative signs. 18, we have 2 because it's even. 2 times what is 18 is 9. I look and see if any of those are prime. 2 is. 9 is divisible by 3. So 3 times 3 is 9. And then 3 is only divisible by 1 in itself, so it's prime. 3 is only divisible by 1 in itself, so it's prime. And then I have 60. Okay. Again, it's an even number, so it's divisible by 2. 2 times 30. $30 is even, so it's also divisible by 2. 2 is prime. 15, 1 and 5 add up to 6, so that tells me it's divisible by 3. Then 3 times 5 is 15. 3 is only divisible by 1 in itself, so it's prime. 5 only divisible by 1 in itself, so it's prime. So to actually go through and write the prime factorization, what you want to do is 6 would be written as just the numbers you highlight. So 2 times 3, 12 is 2 times 2 times 3. 18 is 2 times 3 times 3. And then 60 is 2 times 2 times 3 times 5. And I'm going to color code this. I'm going to let 6 be on. That's a mistake. Stick with yellow. So 6 was yellow up here. 6 is here. 12 was orange. Red was 18. And 60 was purple. So this is how you do prime factorization. I'm not worried about exponents right now, just as long as we can get the prime factorization of the number of each term. Okay. I guess I'll break down an exponent, and it's going to work the same for all of them. So if I have something raised to a power, so x to the fourth, an exponent just tells you how many times something is multiplied by itself. So if I want to expand x to the fourth, it's just going to be x, 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 x. Y cubed will be y, 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 because I have a power of 3.